so it's just we're talking about cylinder in this question. How many variables does cylinder depend on? 2. Okay, good. So we have this time we're talking about, so again the last sentence tells you what to optimize, and it's the cost of the metal. So that's not volume, that's surface area.
But we don't know the cost per sheet of metal.
So it doesn't really matter how much it costs per, like, let's say centimeter squared, because it will get cheaper if we reduce the amount we use, right?
Okay.
Doesn't matter on how much it costs. So surface area will be, so let's just label it typically that we know from before. Right? It's dependent on R and H. So right now we know it's 2 pi r squared top and bottom plus the circumference, which is 2 pi r, times by the height, h, will give you the side of the can. Okay, so that's one equation that we know, or that's what we're trying to optimize. What else do we know?
Volume.
The volume is given to be 1 liter. Now you can't use 1 liter. Do you guys know that 1 centimeter cubic is 1 milliliters? I hope you know that. Used to? So 1 liter is actually 1,000 milliliter, which is 1,000 centimeter cube. You need to convert it into the centimeter. So we have pi r squared times h. That's the volume. That's going to equal to 1,000. Okay, we need to convert this into a function of one variable, 1. And you can see which one is easier to isolate in this equation. H. Okay, that means I can make h disappear in this equation. So surface area now is a function of r. So I just reduced some pi r. Okay, so pi r. So we have 2 pi r squared plus 2,000 over r. So that's a function of r. But this is not a polynomial graph, it's a rational graph. Right? If I actually graph it, this would be a rational graph. Alright, so let's differentiate this in terms of r. And we get 4 pi r plus, it's going to be minus 2,000 over r squared. Okay, set that equal to 0. Mathematically, to make sure you don't lose any answers, you should like add it and then solve for the top. But in these real life problems, right, we almost never have to check the endpoints, because the extreme cases of the endpoint in this question will generate like r is equal to 0, which is like a no can, right? Or r is equal to, like, you can use all the r and it becomes a flat sheet, right? Either way, it's not a realistic case. Those are the endpoints, so we don't want at the endpoint. We know that just solving this, keeping in mind that r cannot be 0, obviously, right, will give us the right r. We can do that. Cross multiply and you get 4 pi r cube. Right, so pi r cube is 2,000 divided by 4. So that's okay. So r will be cubic root of 500 over pi. That's 10 times cubic root of 5 over pi. Okay. So when the r is that length, okay, centimeter, we will have minimum. Okay, we will have minimum surface area. So to confirm that it is minimum, we actually should go back to this. Okay, and maybe I should have just added it. Let's factor out 4, and you get pi r minus 500 over r squared. You get pi r cubed minus 500 for r squared. So let's see where this is positive. You know this bottom is always positive, so we just have to consider the top. Where is this positive? And you know it's a cubic function with something that looks like this, right? It's just straight cubic with vertical stretch of pi and a vertical shift of minus 500. So anyway, that point right there is this, the cubic root of 500 over pi. It's going from negative to positive. We know this because it's a cubic function. If the graph goes negative to positive, isn't it a local minimum? So that will be the local minimum. That will generate the minimum surface area. Okay, so when you plug this into the surface area formula, this is what you get. Of course, it's centimeters squared.